Okay, so yeah, I have lots of pens at my house. All right, really quickly for those of you playing along at home, these are the announcements for today. You can read through those on your own. We got out computers for Desmos. We headed our notes. Our notes are going to look like this. If you want your header to look exactly like mine, we're going to jot down notes as we go through Desmos. You do have a unit test in Khan Academy. We're using that as like our review to be ready for the actual mastery that I will give you in class. So guys, whether you do that once or more than once, I'm going to leave up to you, but you should want to do as well as possible because that's like your test review. The whole if we have time, that's not true. We're totally doing Desmos. So yeah, that's everything from the start slides. Let's do some Desmos. So I'm going to go ahead and assign it to you guys so you're able to... Now the problem is I can't assign it to only half of Math 8. So if there are other Math 8 kids out there right now who happen to see this show up on their Desmos, they'll be like, ooh, look, I can do this. So if you refresh your student homepage... Did it? Okay, so yeah. Boom! Way to go, Desmos. Zoe, same thing. If you just, it should have popped up if you were on Desmos.com and logged in. Oh, yep, I see you in there now. So I have Logan, Sophia, Colin, Zoe, Cooper. Everyone else, I don't have you yet. Now I got Sarah. Now I got Ivan. Now I got Sebastian. Now, guys, if you are one of the first people to answer a question and you're like, wait, why are there not more results? Just wait. Like, literally, this is going to populate live data while we go. So if you are like, oh, there's only like 2 dots here. If you wait literally like 30 seconds, I bet more will pop up as your classmates do the activity. That said, if you operate as like, I'll do this at my own pace and space out for 5 minutes. Please don't space out for 5 minutes. We're all waiting for you, right? Like, we are going to use all of our data as we go together. So the first screen you should be looking at says something about 2 numbers having a difference of 8 and a sum of 1. And you should be writing what you think about that. So I've anonymized you guys, but here are some of the responses that we're getting from our anonymous classmates. Notice your names won't actually pop up because I've anonymized you. We've got a couple yeses, we've got a couple no's. Make sure that you defend why, right? You can't just say yes or no. We got to defend why. You don't necessarily have to come up with the answer right now. Just what do you think? Can we have a sum of 1 and a difference of 8? Could 2 numbers have a difference of 8 and a sum of 1? And then at some point when you get done writing, like typing, go ahead and jot down in your notes, sum of 1, difference of 8. So like one of the first things we would write down. So can 2 numbers have a difference of 8 and a sum of 1? Now that I would put on my graph paper, but I've already got other stuff written on my graph paper. Notice I've got difference of 8 up there, and I started the phrase sum of right here. You know, if you are still writing your answer for slide 1, go ahead and move on. Some people are writing really lengthy answers, which I like, but go ahead and move on to slide 2. You just, when you're done typing, you click next. I think sometimes there's a submit button, but if there's no submit button, you just click next in the top right corner. That one, there are 1 person still on slide 1. If you could try to move on whenever you can. It's about tied, guys, of yeses and nos. I will tell you 1, 2, 3, 4, 5, 6. The yeses got it right now. There are 7 yeses. 1, 2, 3, 4, 5. There are 5 nos. So we're almost tied, yeses and nos. Interesting. Now, please pay attention to what the question's actually asking. If it just asks you to type the larger number, you're just typing a number. So if it says type the larger number, when you have two numbers, don't make it super complicated. Like we're just typing a number. That then could have another number that is a difference of 8. Now, in the next slides, you'll see there's a little bit of Halloween magic at play here. It's not Halloween magic. I mean, did they guess the first one? You gave them the first one, didn't you? Oh, it's close. It's October 19th. We're pretty close. You got that right, but you can't read my mind. This is just math, and there's only one number that can solve this. Yeah. You knew this because if you subtract 8 from 5, you get -3. You're not reading my mind. All right, so wait. So a lot, like, you guys are all arguing that there's no mind reading going on here. How could we mathematically show what they're doing and justify that it's not mind reading? Audrey? So they are just taking the number that you selected, let's say a number like X, they're minusing 8 from it, and they're making that your second number. Let's say Y. So if we started to make a table of these results, we could choose a bunch of X's and Y's. So like, if we made our X 8, which a lot of you probably did, our second number was 0. But what if we made our X 10? I'm going to go back and pick some of the numbers you guys had. Logan, what if we made our X 16? What was our second number then? Sophia, if you made your X 18, what was your second number? Colin, if you made your X 7? What was your second number? Yeah, -1. If Zoe, we made our X 32, or our first number 32, what was our second number? 24. Of course, Zoe had to go and pick a really big number. Cooper, throwing in an odd number. If we made our first number 9, what's our second number? 1. So guys, we can do this all day long, and I'm going to go ahead and fill in my gap up there. So these are when Y is X minus 8. Here's this table. Boom. Okay. Sweet. Awesome. Great. Keep moving on. I actually need to stop talking. I'm going to give you guys a few minutes to work. A lot of you aren't as far as I need to let you get. As far as you can get. I just need to stop talking. Huh? You're right. I can turn it back on if you'd like. Kaboom! That's really... Okay, so every year I have to explain this. When I anonymize, all of these names are famous mathematicians. So even though Kelly Miller could very easily be a classmate, it's not. It's a famous mathematician. Well, yeah, because this is my view. I'm just showing you. Like, but when I, on my private screen, hover over you, it tells me who you are. It's fair for me, because I'm your teacher. Joan Berman, you should look up. So if you're ever curious and you're like ahead in the activity, Google your mathematician name. Joan Berman's a really famous mathematician. Yeah, you're probably further down the page. All right. Anyone who's on slide 4 or 5, we need to please stop talking and try to move forward a little bit. We got some more learning to look at. Now, what is interesting about as we get to slide 5 is it's a line of, well, here's Zoe way out here. I'm Zoe. I'm going to pick a really high up number. Just giving you a hard time, Zoe. But yeah, so Zoe made our graph bigger. If Zoe's point wasn't way out here, we'd actually be tighter in on these points. But it looks like a straight line. Now, Zoe, I'm just glad you didn't pick like 500 and then 492, because then our graph would have gotten really big. But yeah, because the points are even. I don't know quite what we mean by even. Ooh, I like this. Whoever is Jean de Alembert. Because there are many different answers to solve the equation, and gotta love a sentence that doesn't end. Oop, there we go. Because the difference between all of the points is 8. Because they correlate. Ooh, correlate. Etta Zuber Falconer. Well, that's a sweet name. Etta Zuber Falconer. That's sweet. All right, so yeah, they all look straight, right? So then we move on. And, oh, come on. I had to say it. I just had to say it. Thanks, Noriko. Thanks, Kelly. You're going to mess up our data. Wow, I wonder who Haisuke is. Alright, for real, make some legit numbers that we can deal with, not a billion.
Wait, can I keep it at 5,000?
No, because then the graph is going to try to show that.
I'll keep it at 500.
Yeah, can we just use reasonable numbers, please? Like, I know I teach middle school. I know that what I'm asking for is a lot. But if we could just use, like, single-digit numbers. Zoe, I don't know if Logan realizes that I'm recording and all of his whininess is recorded.
Oh, I don't really care. Yay! I don't really care.
So, we've got this table for difference of 8. But, sum of 1. Sum of 1. Hey, Sophia, can you pull your number back a little bit? Please and thank you.
It doesn't mess up the graph, it just doesn't show it.
I know, but it's not very useful when that's what we're doing. A lot more reasonable. Now, Noriko, I can figure out who they are if you give me a minute. They're still...
I figured out how this works. I figured out how to know who I am. Read our mind.
Well, yeah, math is a lot of that. This may be too far ago, but there used to be magic shows on TV. And you can stop me there if that's like, nope, never, not ever these days. But there was a, like, math magician person who would come out and be like, okay, pick a number. Now multiply your number by 2. Now subtract 7. And he would do all this stuff, and then he'd, like, write down a number and be like, is this your number? And it was, right? And right, so yes, but I didn't know that, right? So I'm a child watching this TV show, and I'm like, what just happened? Guys, it's an equation. What that math magician did, was just an equation problem. Where he did inverse operations and, like, knew what would happen. So what we're talking about is just a system of equations, meaning multiple different equations. how could we, and depending on how far you are in the activity, excuse me, how could we write an equation for two numbers that when added together make a sum of 1? If the two numbers we use are like x and y, how could you say these two numbers, x and y, sum to 1? Maybe, I don't know, x plus y equals 1. Would that maybe make sense to sum to 1? Ha! Ha! Y'all aren't listening and aren't interacting with me. Ha! So, the question I just asked, would this work?
Yeah.
X plus y equals 1. Please jot down this equation on your paper. Y equals x minus 8. That was our first equation that we have the whole table for. And then x plus y equals 1. Right now, we're not going to worry about the other more complicated equation. Now I will unpause. You can keep going and not be so mad at me. So in slide 10, I'm trying to watch time and make sure that we're going to have enough time. I've got another Desmos activities too. I just didn't know how long this would actually take. I need to teach less. Hey guys, make sure you're reading the directions. Now, what I want to encourage you to figure out is in slide 11, is there a way that you can write it in a y equals form? Because what we said is x plus y equals 1, right? My two numbers when added together equals 1. But is there a way to write it y equals? Because that's like how most math is presented to us, right? Y equals. So, Cooper, I don't know if you skipped slide 5 on purpose, but if I was doing this as a classroom grade, there's no answer submitted at least.
Oh.
Just checking on you. You know, you could write it down. You know how we had graph paper and pencil for what we're doing?
That's too logical.
Slide 13 asks a really interesting question. So guys, I'm hoping that you'll actually take a moment to think in slide 13 and like write a sentence or two, like pretty, a decent sentence or two. I don't often like make these assignment grades because I don't need to. People normally just choose to interact, and that's sweet. But if we're having issues trying to get like decent answers out of people, now I'm not saying if you're on like slide 7 or 8, like jump to slide 13. I'm just saying when you get there, give yourself a moment to think. We've got 20 minutes left, so we're fine on time. We got 20 minutes left. Interesting. Now I'm looking at slide 11. Oh, one of us put it in y equals form. You remembered how? You remembered how to do it? Like how to get it into... Did you remember slope-intercept form, or did you remember how to do the algebra?
I just put in a bunch of... I did equations that I thought would work and simplified math.
Who, what?
Just guessing shit.
Yeah. So, let's chat real quick before we all move on. I'll give you guys like 10 more minutes, then we'll wrap it up. Whoa! E-Hall Pass is working. Sweet. Ivan, you're good. Had you just sent that to me? Sweet. That means the notifications are working now. The notification settings on my computer are a little funky. Sometimes it holds the notification if I'm presenting something. But I'm presenting Google Slides right now, like up on my smartboard, quote unquote, right? That's presenting. So, I don't know. It depends, I guess. Yeah, but they don't know which screen I actually present. So you guys like Desmos, I guess?
Yeah, I should prefer a lot more stuff like this.
Oh yeah. STMath I didn't have enough control over. STMath is the worst.
STMath really was.
I only like STMath because like kind of personalized.
Well, yeah, see, I would rather do STMath. Personalized path.
That was fun. Like I actually liked that. Like
The only annoying part was whenever you get one question wrong on that.
Yeah.
I got one question wrong. I didn't.
yeah, I just skipped it.
Well, you have to do what? Like, was it that personalized path in STMath? That was kind of fun. But I missed one question that had to be my least favorite. Like,
Oh, I can't remember
that laser beam. That laser. The pie bridge. Pie monster. Pie monster is great. Oh, I love pie. I love pie monster. No, Charlotte. Those were awful. What are we talking about? Do you remember the laser beam? You STMath. I had weird. My
Hey guys, so when you beg me to not pause something, but then I give you time to work and all you do is complain about STMath, that doesn't really encourage me the next time to give you the time to work. Instead, I'll probably just say, no, remember that time when you begged me not to pause it? Yeah, I've learned my lesson because you wasted that time talking about how bad STMath is. So when we talk about systems of equations and their solutions, a solution, as we talked about last week, does what for the system? We said it last week. I put it on a Post-it. I actually, in the picture that I posted of the notes from last week, I put one up with the Post-it still on it. and then the other one without. And remember, the solution to the system does what for the equations? We did another activity in Desmos. Nobody? Because I got my notes. It would have been worth a piece of candy if somebody remembered. Makes everything true, right? The solution makes it true. So what we're wondering now is, in these situations, like when we have difference of 8 and sum of 1, is there something that can make the two of them true? Here's algebraically what we're doing. Cooper told us that he remembered how to get this to y equals form. Please have written down on your paper x plus y equals 1. Then what we do, I'm going to write this again. What we do to get it into y equals form is get rid of the x. So we subtract x from both sides. That gives us y equals 1 minus x. But also, up here, we have y equals x minus 8. So what we're asking when we go to solve a system is, can 1 minus x also at the same time equal this other equation, x minus 8? Now, this doesn't always happen. This can't always be true. So sometimes there's no solution. And those situations tell us, well, those lines must never cross. Because if we think about our Desmos activity, when we get one solution, that's because we had two crossing lines. So a situation like this, please, and then I'll unpause the activity, make a really quick example sketch of what we had done in Desmos. So what I mean by that is make your XY axes. Make like your XY axes. And just really quickly, your x minus 8 was a positively sloping line. Something like this. Right? Your 1 minus x was a negatively sloping line. This is all just really, really approximate. And this was what we call our solution. I cannot spell today. And in this situation, the point that made that true, what was the x that made it true? I think it was 4.5 and negative 3.5. So x was 4.5 and y was negative 3.5. Sorry that I cannot spell. So now the second part of this whole activity is saying, do you think, I lost it, difference of 6 and sum of 6. Right, so now what we're asking, then I will unpause it, is can two numbers can't spell today with a difference of 6 and a sum of 6. And now I'm going to unpause and probably potentially just give you guys the rest of the time. We might come back together for the last couple minutes, but you are unpaused now. Everybody has said yes. Everybody has said yes, that is true. Interessante. Are you just totally done? You can work on Khan Academy. I mean, you got 10 minutes. I'm just saying, don't just sit there and stare. Now, Sebastian, once somebody else puts in a challenge, then you can go try their challenge. But like I said, you won't be able to try a challenge until somebody else puts it in. Yeah, a lot of us are on slide 15 or beyond, so I'll talk about that here in a second. So on slide 14, you might write down those two equations on slide 14. If you do, and a lot of us are on 14 or further, so if you do, I believe the two equations that you get are y equals x minus 6 and x plus y equals 6. This is what I want you to get used to doing, though. Once we write an equation that says what we want it to say, let's put it in y equals form. Now, we'll talk more here this week and next week about what y equals form does for us. This is actually called slope-intercept form. So the y equals form is called slope-intercept. But it also lets us build a table, right? I could plug in values for x and get both y's. And then I could figure out, is there ever a value when the y's equal each other? Now, last week we also talked about solving this algebraically, so I am going to pause you again for a moment. With me, please come over here real quick. Let's write down x minus 6 equal to 6 minus x. They're almost like the exact opposite of each other. Positive x and negative 6, or positive 6 and negative x. Ooh. Now wait, 0 would make negative 6 equal to 6. But the question is this right? So I think, I'm looking at what everyone has. We got x equals 6 plus 0, y equals 6 minus x plus 6, x minus y equals... Well, let's check our math. Difference of 6. Okay, yeah, this would have a difference of 6, right? Y will be the x take away 6. Sum of 6, x and y together make 6 if I subtract the x from both sides. Guys, let's try some algebra here. We totally can. Like, I never said we couldn't, so first off, to defend myself. Sorry, I'm just being kind of silly because I'm not like telling you what you can and cannot do. I'm just trying some stuff. So difference of 6, I made y equals x minus 6. So if I made x 12, then y is 6, right? I take 6 away. So I think this is good. Sum of 6, we can add them together. Now, I can write these in a bunch of different ways. I could actually write this as y plus 6 equals x, right? If I add 6 to both sides, so I'm bumping over because I don't want to encroach on there. But these two equations have what I want them to have, right? The sum of 6 and the difference of 6. If I set them equal to each other, check this out, guys, and I would like you to do this work with me if you would. If I add an x to both sides, it gets rid of my negative x over here. But what do I get on the left-hand side? 2x. Now what if I add 6 to both sides? So I get 2x equals 12. What would x have to be then? If 2x is 12, then 1x is just 6, right? So if I divide by 2 on both, no, wait. If x is 6, let's try this out. I don't need this in-between equation. That was correct, but I don't really need it. If I plug it in here, y equals 6 minus 6. Well, then y would equal 0. Okay. If I try it over here, y equals 6 minus, okay, I plug in the 6, y equals, oh, so when x is 6 and y is 0, do they have a difference of 6? Yes. Do they have a sum of 6? Yes. So 6 and 0. Is there another set of numbers that can satisfy that rule? No. This is the only solution. So really quickly, the last thing I want you guys to write, and then I'll unpause this, but you'll probably just have to do it in extensions if you guys are so choosing. Everyone pick up a pencil. I got to know that you're actually like with me. Whatever. Something that you're writing with. The number of solutions tells us something very specific. Number of solutions. You know it's important because I'm writing in my Sharpies again. If there is one solution, I should have probably just written out like O-N-E. One solution. I'm going to go ahead and do that. One tells us there's one XY pair. So there's one XY that satisfies the equations, or that makes things true. There can also be none, so like 0, right? None solutions, no solutions. Tells us this can't be true. So what it actually tells us, it can never be true. And the last amount of solutions we can have, infinity. Any number.
Good afternoon, Phoenix. At the break, could we please have Alex Ishida to the remote office? At the break, Alex Ishida, please send to the remote office. Thank you.
Literally any number can be a solution. Infinitely many solutions. Now, not any pair, but any number. So we might want to specify any x or y. But we can't just say like, oh, what about the pair 2, 3? Is that a solution? I'm not saying any pair, but any number, any x value. So x can be whatever it wants. So choose an x, and then we find our y. So we would choose x and then find our y. Yes, Sophia.
I know there's like a mind trick, almost kind of like the one that you were talking about on TV, where it's like you choose a number 1 through 10, and then like if
Yep. Yeah. And then an animal. And then the color. And you end up with like a gray elephant in Africa. That's, yeah, there's different ones. So, if you want to do something like that, all right, you want to do it? I'll bring wipes around, but then if you want to do it, you can hang out and we can do guess my number real quick. My extensions is math lab, really, because we reserve this space to do math. All right, pick a number between 1 and 10. Well, you can keep it to yourself if you want. A whole number, right? An integer. Then, multiply your number by 2. With your new number, multiply that by 5. Yeah, see, this is what happens when you get all crafty with your numbers. Divide your new number by the original number. Subtract by 7. So take 7 away from it. Your number's 3. No, that was just the first WikiHow that popped up. There's a bunch of those.
Oh, I'm gonna forget my part. I have this really cool card thing that.
All right. Pick a number between 1 and 10. Zoe, you're totally welcome to leave whenever you want to. Multiply your number by 9. Now, add the first and second digits of that number together. If it results in a single number, put a 0 on the end. Like we need a double-digit number. Then, add 4 to this new number. Should be 13. That doesn't make sense. I was about to say, that doesn't make any sense. Multiply by 9. Add the first and second digit together. Oh, never mind. I shouldn't have ever said the add 0. You should have just the put. Literally, they meant add, like add, mathematically add, not put 0 on the end. They said.
Why did it not say anything?
Because they said if one of your numbers is 0, just add 0. Like, if it's a single digit number, just add 0. Because if you have a first and second numbers, add them together. Here, let's try it with Miss Allie. Okay, Miss Allie, pick a number between 1 and 10. Okay, now multiply that number by 9. If that's too hard, we've got some really good mathematicians in here. Multiplication by 9 is tough. Okay, now take your first and second numbers and add them together, like the digits. If you only have a 1-digit number, just add 0 to it. Which that's what Logan is arguing is dumb. Now, add 4 to your current number that you have. I bet you got 13. Woo! All right, Zoe, I'm going to end this Zoom now because I'm sure it's going for way too long. You're so welcome. Have a great day. Bye.
card. There's this really cool thing that my mom printed out off the internet because she's a teacher, so she has to come up with cool stuff for the kids to do. But,
You mean she